Welcome back to ECE 320A. We're in a review video, and this is a review for exam number 4, and it's coming to us from the fall of 2015, and this is problem number 7 on that exam. This shouldn't be an issue. The zeros are the values, the finite values of S that cause the numerator to vanish, and the poles are the values of S, the finite values of S that cause the denominator to vanish. The DC gain, and here I'm qualifying that, if it exists, will exist if we don't have any pole or poles at the origin. And we can already see that, whoops, we have a pole at the origin, which if we set S equal to 0, which is what we want for DC, S equal to 0 is DC in frequency, then we're going to have an unbounded magnitude at DC. Our DC gain does not exist in this particular problem. So we can anticipate that simply by examining the denominator and seeing an S or an S squared or an S cubed sitting out by itself in the denominator. The only hard part about this is the factoring that is done here has actually messed up maybe the traditional look. It's not time constant form, it's not pole zero form, it's a mess. It's a mixture. So we need to really just keep track of that. Let's now look at the zeros. We have 10s plus 2, that needs to equal 0. Or we now have 10s is equal to minus 2, or s is equal to minus 1/5. Hopefully that's now one of our zeros. The other zero is when the factor s plus 5 is equal to 0, and that's when s is equal to minus 5. So we already have our zeros. The zeros are at s equal minus 0.2 and s equal to minus 5. And we have 2 of those. For poles, we've already said we had 1 at the origin. S equal to 0 will cause the denominator to vanish. We have another one at a value of s that causes 4s plus 1 to vanish, and that will occur when s is equal to minus 1/4. So there's a second pole, and we have one more pole, and that one is coming to us pretty cleanly. That's now at s equal to minus 10. If we just went through and tried to evaluate for the DC gain, this would blow up because now we're evaluating this denominator polynomial at s equal to 0, and that says we're dividing by 0. So the DC gain in this case does not exist, or non-existent. And that's all there is to this particular problem.